At this point, we can start looking at adding sensors to our taskbot in order to create a more sophisticated robot and looking at the programming constructs in order to use the sensors in order to create more sophisticated programs. So the NXT comes with a variety of sensors. So there's 4 main sensors that come with them, and this is a picture showing the NXT brick. The important thing to note with these sensors is that they connect to ports 1 through 4, while the servos connect to A, B, and C. Okay, so anytime you put a sensor in there, make sure you connect it to 1, 2, 3, or 4. So let's go through the 4 basic sensors that come with the NXT. The first one is going to be a touch sensor, and this sensor it looks like a little button. So when you pick it up, you can push this orange actuator right here, and it feels just like a push button. And the way that this works is it provides a true-false reading when pressed. So when you think about going back to our programming constructs of making a decision, the decisions were always based on true-false. So it wasn't necessarily things like things that were arbitrary. It was always things like, is there something in front of me? If so, if true, turn right. Or you can use numbers in the decision, but the numbers were always things that resulted in true or false. So questions that have an answer of true and false. So is a number greater than 7? Is the number exactly 255? So these sensors provide this true-false reading that is then used back in the programming construct for a decision. Now what typical uses for one of these touch sensors is it can be a start-stop button. So a lot of times you'll just have this on a cable, and you just use your thumb and start and stop the robot. So it's kind of like an on-off button. Or another common use for it is a bumper. So you can actually put some of the other pieces inside of this. There's a little hole in here that you can put one of the axles in, and if it runs into a wall, for example, or runs into an object, it'll press the button and then you react accordingly. The next sensor is a sound sensor, and this sensor you can tell it's a sound sensor. It has the microphone on it, but also it's got kind of like almost like an orange microphone cover, one of these little kind of spongy looking things underneath this cage. And the sound sensor detects audible sound, and what that means is it detects levels that the human ear can hear. So that's defined usually as 30 hertz up to 20 kilohertz, and this again provides a true-false reading when it's detected. So you use this in a decision construct. So was there sound or was there not sound? And it doesn't give anything necessarily more than that. You can do some stuff with levels. You can say, is it above this sound decibel? Is it below this? But the end result is once you set this up in the decision, it's going to be a true-false. So some applications of this are things like, you can use a audio command to make the robot do something. So a real common one is like a clap. So if you hear a loud noise such as a clap, the robot might spin around or might start something. And it can also do things like react to a doorbell or a knock. So you can imagine that the robot waits for the doorbell to ring and then does something. So that's the sound sensor. And then we have a light sensor, and the light sensor is really simple. It just distinguishes between light and dark. And there's kind of 2 modes of operation on the light sensor. There's one that's just a receiver, and it receives the intensity of light in the room. So you can set it up to say, if you turn on the lights, the light sensor will say true, the lights are on, and then you can do something, or false if the lights are off. So it'll actually read the intensity of the room light. But then it also has the ability to distinguish between light intensity of colored surfaces. So what you'll notice is when you look at this, there's 2 they look like little LEDs, and one's a receiver and one's a transmitter. So when you're in the, measuring the intensity of the room, you only use one of these. You just use the receiver. But you can use this to try to do things such as if you point it right down at the surface of something, so the ground, you can look for differences in color, like light and dark. And the way that it works is it actually transmits a light. So it outputs a light, and then it looks at how much of that light was received. And so the light will either be absorbed or reflected based on the color, and you can actually then measure how much is reflected back into the receiving terminal of this. And this becomes really good for doing things such as line following. So imagine that you put a line on the ground and you program your NXT to follow the line. drawing. So you can use that for a variety of applications. You can have that, draw lines on the ground and have the robot walk through an office building and do tasks, or you can bound the robot. So this is a really common one where you say, I'm going to program the NXT to do some task within a boundary. Well, how do you know what boundary is? Or you put down a piece of tape, let's say a piece of electrical tape, which is black, on a white surface or a white floor, and you draw a big circle around the NXT, and then you don't let the NXT ever leave that. Okay. Another clever example is a burglar alarm. So imagine that the NXT is just sitting there waiting, and then somebody comes into the house, turns on the light, and then the NXT starts making beeps and running around trying to run into the foot of the burglar. So that's an application there. Then finally, you have the ultrasonic sensor, and this one is really neat because it measures distances to an object, and it can measure between an object between 0 to 255 centimeters. So the way that this works is it transmits an ultrasonic pulse, and so ultrasonic means that it's out above the audible range of the human ear, which is above 20 kilohertz. And then what it does is one of the eyes is a transmitter, and it outputs the pulse, and then the other eye is a receiver. So the sound travels down, it strikes an object and reflects, and then it travels back and is received. So what this sensor does is it will calculate the round trip time between when it sent the pulse and when it received the pulse, and it knows that that was 2 times the distance to the object. So then what it can do is, since it knows the speed of sound, it just does distance equals rate times time, and it figures out the actual distance to the object. So this one is really powerful for object detection and object avoidance. And this one is used, it looks like a robot, so it starts giving the humanoid appearance to the NXT. So students really like this one, and this one really gives you the ability to make intelligent decisions, and you use it in conjunction with these other sensors, and you can get pretty sophisticated tasks to be accomplished. So that's the overview of the NXT sensors, and let's just do really quick how you would use one of these sensors in a decision construct. And we'll just do a simple example of it just to give you a taste of how this is going to work. So here's what we're going to do. Let's go ahead and bring up the Mindstorms software. And what we're going to do is we are going to use the touch sensor. So go ahead and grab your touch sensor, and this is the one where you can press the button. And let's just attach this to port 1 of the taskbot. So I'm just going to plug this into port 1. And what I want to do is I want to make a program where if I press the button, it'll make it move. So I just want to use this as a start button. So I'm going to press the button and have it move forward just a little bit. And it's really not doing anything too complex, but I just want to see how these sensors interact, and I want to look at this first decision construct. So I'm going to go ahead and power on my robot. And at this point, what I'm going to do is I'm going to come over here, and I'll just do a new little program. Let's just call it touch example. And what I want to do is I want to put down what is called a switch construct, okay, or a switch block. And so the switch right here, go up into common, then come over to switch, and the switch is the decision. So if I put this down, I'm going to put it right here. What it shows you is that you can take one of 2 paths based upon a true-false reading of one of the sensors. So in this situation, when I click on the switch block, then you come down here into the controls, and you can see what is the control going to be, and you can choose sensor or a value. We're going to use sensor because it's going to decide which path to take through the switch based upon the value of a sensor. And what we want to do is then choose which sensor we're going to do, and so you can see all these different sensors on here, and we're just going to use the touch sensor, which is the default one. And then I come over here, and you can choose which port to put it on, and let's just put it on port 1. I mean, that's where we plugged it in. And then what we do is you can set up the condition, which is pressed, released, or bumped. And I'm just gonna put pressed. And then what I can do here is I'm gonna go ahead and plug in the NXT. So I come over here and I plug in my USB cable. And at this point, the NXT is programmed here, or excuse me, is connected, and everything's good. And so now I'm ready to think about what I want to do. So let's go ahead and just make this move if it's pressed. So you say, okay, I'm going to come along here and I'm going to put a move. And where do I put it? Do I put it in this path or do I put it in this path? Well, if you look at it, if I put it in this path, notice that this result, or this path, will be taken when I have a 1 or true off of this result of the switch, and that means it's pressed. So they kind of try to give you a graphical notation, so the arrow's going in, so that means this is true because we press the button, and this is a 1. In the way that the logic works on this is a true is a logic 1, or a false is a 0, so it kind of maps into these binary numbers. But anyway, what's going to happen is that if I press the button, this will actually move a little bit. So now I come down here and let me set up my motors. I remember that the left is on B, right is on C, and all I want to do is, let's just make it 50% power and do 1 rotation. And at this moment, what I can do is I could download this. Okay, so I could go ahead and hit run. So let me just download it and run and see what happens. So I come over here and nothing happened. Okay, nothing happened. If I push the button, nothing's going on. And the reason that is because when I downloaded it, what happened is that this switch construct saw that you didn't have the button pressed. It went through this empty path and then it ended. So nothing really happened when I downloaded this. However, if I held the button down and I did it, then what would happen is that when it runs for the first time, it came through, it said, okay, I saw the button be pressed from go and I moved it a little bit. Okay, so now in order to keep this going forever and ever, what I have to do is I have to combine this with the loop construct. So what I'm going to do is I'm going to come back up into common and I want to get a loop, and I'm going to put this loop right here. And then what I want to do is I just want to drag this switch construct and our move into the loop. So now in this situation, what I can do is it will go forever. So that means if I push the button, it will move, and if I let go, it'll just stay. And what I'm actually doing is when I'm not pressing the button, the computer is actually executing the loop. It's just that it comes through this path right here and does nothing and then loops back. So most of the time it's in there. Now, another really powerful thing that happens is once you download the first program, and if I push this, take a look at what's going on in the bottom left-hand part of the switch. So you got to make sure that you select the switch, and you can see down here that this 1 and 0 is happening. That is corresponding to when I push the button. So you can actually, this happens after you download for the first time and the cable is connected. It's actually reading what's going on the NXT, and this is a really powerful thing because you can press the button, see what the switch construct is going to observe. So I know that I have it set up that if I push the button, it says a 1, and then it'll take the path corresponding to the 1. So this is a powerful debug tool. Okay, so let's take a look at, let me run this. Now I'm only downloading and running because I know that I'm not going to go very far. But at this point, let me put it like this, and what I'm going to do is if I push the button, it goes forward. And then I just let go of it. And then if I push the button, it goes forward. And it works. So this is the basic overview of how you use a sensor to make or to drive the decision construct within the Mindstorm programming or programming tool. And of course the decision is called a switch, but that's not a big deal. It's just that's what the terminology is. Okay, so that's how we do it. And so now at this point we kind of know where we want to go, but we don't have any sensors. We don't have any real sensors on our taskbot. So what I want you to do is we need to add some sensors. And so I just came up with this very simple way to add the ultrasonic and the light sensor to the front of the taskbot. And this will allow us to do things such as a line following algorithm, which we'll use the light sensor to follow a line. And then we can use the ultrasonic sensor to do object detection and avoidance. And so the way that you do this is there's another building plan that is provided, and I put this together, and what I did is I just took pictures of it, so hopefully it's very self-explanatory. This is what we're going to do, and what I did is this is the piece you're going to build. So you can see that you have the ultrasonic up here and the the light sensor here, and when it's completed, it'll look like this, and it'll snap onto the front of the taskbot. And so then I give you a couple different views of how it's going to work, back view, top view, and then what I do is you can see all the sides, and then I took the entire thing apart and laid it out, so you can see that you're going to use some of these pieces here, and you're going to use the axles and these yellow stoppers on here. And so before the next video, go ahead and build this robot or add the sensors to your taskbot, and then what we can do is we can come back and we can start looking at more advanced programs. So we can look at obstacle detection using the ultrasonic sensor, and then we can look at line following algorithms or staying within a border. And this module consists of 3 videos, so I have a green check saying we have 2 more to go. So notice that it's going to take 3 small checks in order to complete the sensor module. But that's the next step, so go ahead and add those sensors to your taskbot, and then we'll continue on with making decisions.